Hello everyone and welcome to your lesson of physics, chapter number 1 of AS Physics, Physical Quantities and Units, and we are starting off with the topic precision and accuracy. So let us define precision. In simple words, precision is how close the measured values are with respect to one another. So it indicates how close multiple measurements of the same quantity are to each other or to one another. Now that is the thing, that if the reading is written as 1 centimeter and another reading is written as 1.0 centimeter, these readings, the measured value is same, but they are representing different precision. This value is more precise than the first one, because in the second one you were able to measure to a tenth part of a centimeter. Let us take a look at the data set. So we have the first row in which we'll be comparing all the measured values, and then we have the second row. So if we talk about the first one, what you see, the first reading is 2.9, the second one is 3.2, the third one is 3.1. So the measured values are very close to one another. Alright, there's a maximum deviation between the values is 0.3. So the range, we can say the range is 0.3. So that's quite a small range compared to the values that we are measuring. So we can safely say that this data set is precise. These readings, these measurements are precise. Now if we compare the second row, if we compare the three readings in the second row, the first one 8.6 and 5.1, there's a difference of at least 3.5, like 3.5. That's such a big difference compared to the readings that we are measuring. All right, so another thing is, and that is a very important thing, that the difference in the readings depends on the reading itself. Only then we can assume if the difference is large or just non-significant. For example, in this data set, the maximum difference is like 5.1 if we could sort it out. But if we were measuring the quantities, for example, one is 100,000, the second one is that much, and the third one is, let's say, now in that case, a difference of 5 or even 10, that would be seen as a very small difference or variation in the data. So keep it in your mind, whether or not the difference is huge or non-significant depends on the measurements themselves. So for this data set that we have written in the second row, these are very small readings, and compared to those readings, the deviation is very large. So we can say this is not precise. Then we have the next thing, which is called as accuracy. So accuracy simply means, as the word is saying, how accurate your value is. So you're taking a measurement, and if your measurements or the readings are close to the actual value, then the readings are accurate. It tells you how close the values are to the actual value. Okay, so the next thing about the accuracy is it depends on so for the accuracy we have these two things. In simple words, accuracy is how close the values are to the actual value. For example, if you want to measure the thickness of a sheet of paper, and what you have done is you are using a meter rule. Alright, you're using a meter rule or a tape measure for it, then the accuracy would be reduced. Now examples. Now you would have studied, and you will be studying, that we use the value of gravitational field strength as 9.81 in O levels, or IGCSE physics we use it as 9.8. And even before that, we used to round it off to 10. But here in A-level physics, we'll be using it as 9.81 Newton per kilogram, or acceleration of free fall as 9.81 meter per second square. This is the actual value that we have to measure. The true value is 9.81. Now student A performs the experiment, and the values that he comes up with are, for example, 9. Let's say 84, 10.02, or 9.79. And the student B, he comes up with the values 6.75, 6.74, 6.73. Now if you compare the two readings of the student A and the student B, you see the readings of the student B are very close to one another. So these readings are precise, right? This is what we study for the precision. If the values are close to one another, the readings or the measurements would be called precise. Compared to the readings of the student A, those readings are close, but not as close as the readings of the student B. So comparatively, student B's his readings are more precise. And compare once again, only comparatively, the readings of the student A are less precise. But if we compare the readings to the actual value, you see the actual value for the experiment or for the measurement has to be 9.81 something. Now which one of these two students got close to the actual value? The answer is student A. Like most of his values were 9 point something, one of them is 10 point something, but the difference is very small from the actual value. So we can say the readings of the student A are more accurate, and the readings of the student B are not accurate. So once again, in simple words, precision is the values are close to one another. Accuracy is the values are close to the actual value or the true value. Okay, let us take a look at some of the graphs here. Alright, so here we have these graphs and some of the pictorial representation of precision and accuracy. First one, I'm going to represent the data that is precise as well as accurate. So that will be precise as well as accurate. So for example, let's say this is the true value, or this is the target, this is the measurement, this is the exact value that you should be achieving from the measurements. Alright, whatever number of readings you take, but the final answer should have been in this range. Alright, so let's say the first reading that you had taken stands over here, the second one stands over here, the third one stands over here. And this was the target, this was the range in which the true value lies. So we can say that the measurements that we have taken are close or within the range of the true value. Also, the three measurements that we have taken are very close to one another. So the readings are precise as well as accurate. For the second one, let's draw a situation in which the readings are accurate but not precise. So for example, the first reading lies over here, the second reading lies over here, the third reading lies over here. Now these readings are within the range of the true value, but they are not very close to one another, or at least compared to the first case. So we can say that the readings are accurate since they are close to the true value, but the readings are not close to one another, so the readings are not precise. So for example, the first reading that we have taken lies over here, the second one over here, the third one over here. Now the three readings that we have taken are very close to one another, so we can say the readings are precise check, and the true value was lying over here, so the readings that you have taken are not close to the true value, so we will say the readings are not accurate. And the readings that we have obtained in this situation are, the first one lies over here, the second one lies over here, the third one lies over here. Are these three readings close to one another? No, so the precision is not there. Precision cross. Are these three readings close to the actual value or the true value? No, so the accuracy is also not there. Accurate cross. Alright, so let us draw the graphs of these measurements. For the first one, when the reading is precise as well as accurate. So for on the x-axis, I'm going to represent the value or the values that we have measured through the experiment, and on the y-axis we are representing number of values. Alright, so let's say we were calculating the value of g, which is, once again, the actual value is 9.81. The actual value lies over here, 9.81. That's the actual value of g. And the measurements and the values that we have obtained are plotted as something like this. Now, what does that mean? This graph represents that most of the values of g that we calculated lies over here, lies close to the actual value. So that means the measurement is accurate. And also at the same time, there's a kind of a very less deviation between the maximum and the minimum value that we calculated during the measurement. So that means there is precision as well. Alright, the width of this peak, the width of this mountain is quite small, and that would tell you if the readings are precise or not. If the width of the mountain, the width of this peak is narrow, if it is a narrow one, it means the values are close to one another, so that would be precise. Let's take a look at the second case. So once again, we have values here, and here we have the number of values. And if we plot the data, if we plot the graph for something that was accurate but not precise. Accurate means the peak or the most maximum number of values should be close to the actual value. Right? This is your actual value. And here it was also your actual value. If the peak lies above the actual value, it would be an accurate one, because most of your readings are there close to the actual value. But the thing is, in the second one, since it was not precise, you'll see this kind of shape. Now how is it different from the first one? The width of this graph has increased compared to the previous one. What does that mean? It means there is a lot of difference between the measurements that you have taken. So the more the difference, the more the variation, the more the deviation, the precision would be reduced. So this one is accurate because the peak is right above the actual value, but the width is quite a lot. So that means the values are accurate but not precise. Okay, let's move on to the case 3, in which the values were precise but not accurate. Okay, so let me label the axis values here and the values that we have recorded, and here we have the number of values. And let's say once again, this is the place where the actual value should lie. Alright, so your readings are precise means the width of the graph would be narrow, but the peak of that graph would not be above the actual value. So it can be something like this. So what do you see? The peak, the maximum number of values are not close to the actual value. This is not accurate. But the graph is a narrow one. That means it is precise. The readings are precise, but they're not close to the true value. Right? You get these graphs in paper 1, you get them in paper 2 as well. After that, we'll be solving some sample question and I'll show you there. Or it could have been on the other side as well. Alright, depending on what kind of values you have. If your values are below the actual value, the graph would be on the left side of the original. If your values that you have measured are above the true value, then the graph would be shifted on the right side of the actual value. In the last case, you have something that is not precise, that is not accurate. So values here, number of values here. Alright, the same stuff. And here you have the actual value of g. If it is not precise, means the graph would not be a narrow one. The spread of the graph would be increased. If it is not accurate, that means the peak would not be above the actual value. So it can be something like this. So you see the peak of the graph, the maximum number of values are not close to the actual value. So this is not an accurate one. And the width of the graph is also quite a large, so that means the values are not precise, they are far away from one another. Alright, so let us move on to some of the sample questions and see what kind of question we have. The measurements of a particular time interval is repeated. Many times the readings are found to vary. The results are shown in figure 1.1. And you have the readings and number of readings. You see, it's pretty much the same graph that we were drawing. They have given in the form of bar graph. If you want to draw it as a continuous one, it would be this shape. And then you can relate to the previous cases that we have studied already. Alright, state the expected changes to figure 1.1 for the experimental measurements that are more accurate. If the measurements are more accurate, what would be the change in the figure 1.1? If the measurements are more accurate, then the peak of the graph would be shifted towards the actual value. For example, this one. If it was accurate, the peak of the graph was always towards or above the actual value. So what we can write here is, for more precision, once again the thing was precision in the graph is represented by the width of the graph. So the more the width, the less the precision, because that tells you the values are very far away from one another. And in order to increase the precision, the values have to be close to one another. So the values here are represented by the lines or by the bars. So we can say the bars have to be close to one another. And once the lines are closer together, you'll be getting a sharp peak. That are close to one another, you'll be getting a sharp peak. So this one is not precise, but if the values are precise, you get a sharp peak. And this one is even more precise. So the sharper the peak, the more precise the values would be.